Good morning, guys and ladies. Let's look at today's daily task. Minimum operations to make uni-value grid. What is that?
Uni-value grid.
Uni-value grid. Great. You're given 2D integer grid of size m to n and an integer x. You can add x or subtract x from any element in the grid. A uni-value grid is a grid where all the elements of it are equal. Return the minimum number of operations to make the grid uni-value. If it is not possible, return -1. Okay. Output 4. 1, 2, 3, 4. Yes. And okay. Here output 1, 2, 3, 4, 5. 5. And here we have -1. Okay, got it. Got it. X is integer. Okay, what we should do here? I would say that we should make sure that we have the same divider. Let's just imagine that we have grid like let's say this 3 5 5 3 and x equal to 2. What can we do? We should calculate the divider or the remainder would be grid 0 remainder from division to x. It would be equal to, in our case it would be equal to 1. After that we can make a loop through the array. Okay, let's see all the conditions. M is grid length and grid I length. Always bigger than 1 can be pretty big, 100,000. Okay, got it. And x cannot be really extra big. And what else? Integer grid, so all of them are integers, which makes everything much more simple. Element of the grid, let's say that const m would be equal to grid length and would be equal to grid first length. So remainder would be grid divided by 1. So, and I would say that it doesn't matter for me that we have 2D array because all we need to do is to find the, how to say, deviation. Yeah, deviation from the original number. Okay, here we can see, for example, if we will have -3, what then we will do? -3 to -1 integer. We only have positive integers. Well, and it's okay. For example, we have -1. Let's say -1. Then const deviations would be an array of length m multiplied by n, and it would be, yes, for let mi equals to 0, or we can make it simple, const subarray of grid for const value of subarray. Then we can calculate our deviations. Deviation would be value minus remainder divided by x. If number is integer, deviation. If it is not an integer, then we return -1. For example, in this case, deviation would be 1 for 2 minus 1 divided by 2 would be 0.5, and we will return -1. Okay, and what kind of deviations will we have? -3 minus -1 would be -2 divided by 2 -1. 5 minus 1, 5 minus -1, 5 plus 1, 6 divided by 2, 3. 5, 6 divided by 2, 3. 3 is I need to charge my notebook, laptop. Okay, and last one, 3 deviation would be equal to 2. And now we need to find the closest number between them. So, deviations. Okay. Yep. We don't even need deviations, but we will simplify it a little bit later. Const deviations summary would be deviations reduce from 0 previous plus current, previous plus current. Yep. And deviation summary. What do we need now? Const values count would be m multiplied by n. Average deviation would be we need to find an average one. Deviations divided by values count. So in our case, deviation summary would be -1 plus 3, 2, 5. -1 plus 3 would be -1 plus 3 would be what? 2 plus 3 would be 5 plus 2 would be 7. Yep. Average deviation would be math round values count is m in our case 2 and 2 values count is 4 and 7 divided by 4 would be 3.75. 1.75 math round would be 2, which means that the closest number between all of these numbers is 2 multiplied by 2 is 4. How many iterations do we need to make it to 4? 4 minus 3 is 1. Oh, it would be not 4. Const desirable number, let's see, would be average deviation multiplied by x plus remainder, and it would be 4 minus 1 3. From -3 to 3 it would be -1 1 3. 4 5 it would be 1 3 4 5. So we will have 5 iterations. Well, which is pretty good. 1 2 3 4 5 iterations. If we would take, for example, 1 not 3, then we would have 1 2 3 4 5 6 7 iterations, bigger than we desire. In this case, initial values count would be 4, remainder would be 0, deviations would be 1 2 3 4, summary of deviations would be 1 plus 2 plus 3 plus 4 10. 10 sum 10 divided by values count, 10 divided by 4 would be 2.5. We will round it to 3, and 3 multiplied by 2 would be 6, plus 0 would be 6, and after that we are counting the distance. 1, 2, 3, 3, 4, and the result would be 4. Here we have 4, but it doesn't matter for us. The result is just the same. So what we need to do is to go through deviations or not. You can go through the grid. Result would be 0. Go through grid, desirable number. Here we have value, and result would be equal to math absolute between desirable number value minus desirable number divided by x. For example, here 2 minus 6 would be minus 4, divided by 2 would be 2, math apps divided by 2 minus 2, math apps would be 2, and we will return result. I would like to check my solution before simplifying it, but I think it should work. M grid length and grid 0 length. We know that n and m is always bigger than 1. Then values count. Yep. Remainder. Yep. Grid. We can modify grid here just not to calculate remainder twice, but I don't think it's critical. Then we have deviations, subarray of grid, value of subarray. Deviation is value minus remainder divided by x. If it is not an integer, we return -1. Yep, because we should be able to use remainder from first element to all the other elements. And if everything is right, then we push it to deviations. After that, we summarize all the deviations. We calculate average deviation, and we calculate the number that we want to find, that we want to calculate the distance to, and it would be average deviation Yep. Multiplied by x. Yep. Plus remainder. Yep. After that, we'll loop through this 2D array again and calculate the result. We summarize the distance between current value and our desirable number divided by x to count the number of steps. Result can be negative. This is why we get moduli of this result. Now let's try to run. Let's look at GIRT. Yep. Let's type GIRT. Interesting. Output -1. Expected output 4. Let's debug it. Remainder. And deviations. Let's look at that. None. Yo, yeah, of course. Pre. Yes, a lot of mistakes. I would say stupid mistakes. Yes, now everything works, so the algorithm itself is good. We can simplify it a little bit. So deviations would be this. I think we can, what we can do, we're using extra memory right now. We can calculate deviation sum here. It would be initially 0, deviation sum would be summarized with deviation. Here we don't need this calculation anymore. Deviation sum. Yep. It works. Interesting. How can I simplify it? Can I make it with one loop without the need to make second one? Okay, let's submit and check if all the cases are covered. Nope, not all of them. Output 26, expected 25. Interesting. Let's look at this number. I would like to see if we round it correctly. 6.2 is the minimal number of the average number, and if we round it, it would be 6. So let's look at these numbers. Map x divided by 92. 75. Okay. Percent 92 69 x minus 69 divided by 92. Five, 10. If we summarize it, then we will have reduce a plus b 0 56 divided by 1 2 3 4 5 6 7 8 9 6.2. This is fair enough to say that the average number would be 6. Why not? If we are having 6, then how many iterations will we need to make it to 6? 1, 1, 4, 4, 1, 3, 4, 2, 6. We will need 26 iterations. Okay, if we will make it 5, then 0, 0, 5, 5, 0, well, 2, 5, 3, 5. Wow, we will need 25. Well, why? Why don't we take the medium value here? What kind of value do we need here? Like median or something like this? Maybe, but why not medium value? 6 point. It's strange. Let's look at hints. Is it possible to make two integers a and b equal if they have different remainders? Okay, I got it. If it is possible, which number should you select to minimize the number of operations? I don't know. What if the elements are sorted? Do we really need median? So we really need median. So median is this value. If it's median, then it would be better to have deviations array. Deviations sort a b, a minus b. Const median would be deviations math floor deviations length divided by 2, and desirable number would be median. Oh no, it would be average desirable number would be median multiplied by x plus remainder. Let's try. Let's try to submit. Yep, it works good, but I don't still understand why is median the closest. Is median closer to the most of values than the average value? For example, just in my case, I have minus 3, minus 2, minus 2, minus 2, 3,000. 0, 0, 0, 1. Median would be 3, 4, 5, 6, 7, 8. median would be -2. And the result would be -2. H 0 0 0 2 2 2 3. If we will take average value, then what we will have? 3000 minus 1006 plus 1 divided by 8 minus 375. Minus 376. And after that, map value math apps value plus minus 376 Yep. Yep. We need to take median value. But here we need to sort it before taking. We don't need average deviations anymore. We don't need deviations sum anymore. We just need sort, which would make our algorithm space would be O of n, because we need to construct additional deviations. Array time would be O, big O of n multiply by logarithm n. Okay, desirable number. We need 2 loops anymore. Well, I think that's it. Let's look at other solutions. Sorting and median. So yeah, yep, got it, just the same as mine. Great. Okay, guys, I think we did a good work today. Thank you very much.